Hello everyone, my name is Brianna Hurst and I'll be presenting on the healing rates of scars on bottlenose dolphins in varying natural salinities. So I have been interning in Dr. Dara Orbach's Functional Anatomy and Behavioral Ecology lab here on campus, and over a semester of doing photo identification, I began to wonder what affects the scars and the wounds that I was seeing on these bottlenose dolphins. And so my first thought was to look at salinities, seeing as they live in a marine environment. So I did a little bit of background research, and I found that there really isn't a lot of studies that have been done looking at salinity and how it affects cetaceans, let alone bottlenose dolphins. I did find one study on low salinity exposure over a very long time. There on the right, you can see that paper, and on the left, you can see a paper on how salinity affects skin wounds in pigs, but there really hasn't been anything that looks at how salinity affects the specific wound healing in bottlenose dolphins. So it was apparent that there was a need for further research. So I began looking at Rizzo's dolphins, which are known to accumulate so many scars throughout their lifetime that they eventually, as they're older, they will turn white. And they get these tooth rake marks, as you can see, through battling each other. And it's thought that this shows potential mates that they are stronger, they've survived a lot of battles, so it makes them more attractive to a mate. But not all species of dolphins scar like this, so this is a pretty interesting case here. So I wanted to know how scars work in common bottlenose dolphins, which is what we have in our area. And here you can see a bottlenose dolphin with a propeller strike going down its body. And this is a very different looking scar than previously you saw tooth rake marks. And so looking at sources of scars and how they heal, that's going to be a big factor in how salinity is going to affect those scars. But we use these markings because they help us identify individuals over and over again. So you can see nicks and notches on the dorsal fin there. If those propeller scars are long lasting, we can use those to help identify this particular individual for years to come. So the study focus was here in the Corpus Christi area. We were looking at Corpus Christi Bay and the upper Laguna Madre. And this is a very unique area to study because the Laguna Madre is one of only 6 hypersaline lagoons in the world, according to the National Park Service. So its salinity values are usually above 36 parts per thousand, whereas Corpus Christi Bay is a hyposaline environment. So it's below normal ocean water. So it's usually within 22 to 27 parts per thousand. So that's considerably lower. So this makes it a really unique area to conduct our study. So we wanted to calculate the change in the amount of scarring between our 2 different sites with their varying natural salinities. And we hypothesized that there's going to be more change in scars in dolphins from Laguna Madre, which is the higher salinity environment, compared to Corpus Christi Bay, which is the lower salinity environment. So we worked in a catalog that has been maintained by Dr. Dara Orbach, and we recited individuals throughout this catalog to find matches in Corpus Christi Bay and Laguna Madre. And this is an example of what their dorsal fins look like, and we choose dorsal fins because they're easier to spot. They come out of the water more often, but of what their dorsal fin looks like over the course of this study, which the years we were looking at were between 2014 and 2020. So that's a pretty long time. And the first one on the top there, you can see the majority of the scars have changed and they're gone. They're really hard to see again. But we know that this is probably the same individual due to the notches down the trailing edge of the fin there. Whereas on the bottom, there's more scars that have accumulated over the fin, so they could have covered up previous scars. So this just kind of highlights some of the challenges when we're trying to reliably identify these individuals. So we need to know, how long can we use these scars before something like them disappearing or getting covered up happen. So we used two methods to measure these scars. One of them was linear length. So we took the longest length of the scar. And this is because a lot of toothache marks are really thin. There's not much width to measure, but there's a lot of length. So we wanted to see how much change there was on these individual scars. So we measured the longest length of all the scars. And then because some of the photos, the dolphins are very far away, or they're up close, or they're cropped differently, we needed to scale the photos. So we used the longest length of the dorsal fin, so from the highest point to where it meets the base, to act as a ruler. That way we could get a ratio of the sum of scars on the fin from before and from after. So to get our percent change, we use the formula sum of old minus sum of new divided by sum of old times 100. And here's what that looks like for our linear method, where most of the scars, as you can see in that photo on the right there, have been completely healed. Only one of them, you can see the 0.051 units. That one's reduced a little bit, but it's still there. So you can see the amount of change between 2014 to 2020, that's 6 years. So pretty significant amount of change. And our second method was looking at surface area. So we wanted to know the overall entire area of the scar on the whole fin. How does that change? And is it different? How much different is it from linear length? Because we're trying to find a reliable method to even measure these. So we traced the entire outline of the dorsal fin, and we used that as our ruler. We set that to 1, and then we measured the surface area of the scars inside. We added them all up, and we used our same percent change formula to get our measurements for surface area. So once we had all of our important data collected, we wanted to look for patterns, and we found that the Laguna Madre individuals, during the new photo, the second photo, they were all found in a higher salinity value or level than the first photo. But in Corpus Christi Bay, we only had a few that were in higher, and then there was a couple that were in lower salinities. So there's a bit of a variation there. And we also found that there was not a large difference between our linear method and our surface method. As you can see all the way there on the right, most of the values are pretty much the same or within a couple digits of each other. So we found that both of our methods were pretty similar in their results. So we wanted to see what our percent change was between our two study sites. And we found that Upper Laguna Madre had 100% change in scars. So that means that all scars were completely healed by the time they were resighted, whereas there's a bit of a range in the Corpus Christi Bay resightings. However, our sample size was pretty small, so these results aren't significant. However, this still supports our hypothesis that there is going to be more change in Laguna Madre. And we wanted to look at our patterns from a different viewpoint. So we have this plot here where we have the total amount of scar length on an individual, and we wanted to see what the salinity value was for each time we saw it, to see if the scar length is changing if it's in high salinity versus low salinity. So as you can see, our individuals are color-coded. In a circle is the before, and the triangle is the after photo. And we wanted to see if there's a change or if there's a pattern here on what the salinity level was during their resighting. And again, our Laguna Madre individuals were always in a higher salinity value than before. So this study found that all the animals in Laguna Madre, or the high saline environment, healed 100%. And there was a range in the Corpus Christi Bay data. So there wasn't really a clear pattern going on there. So this tells us that we definitely need a bigger sample size so that we can keep going with this preliminary data. And we also need shorter time intervals between our sightings. So studies that are doing long-term photo identification should probably try to collect data more frequently so that they have a better chance of having shorter time intervals between when they're resighted compared to having 6 years between sightings. Future studies may also focus on other water parameters that can affect scar healing. So we want some future questions could be, is temperature a factor, or how, or other qualities in the water. There's one study that looked at um, scarring, and it mentioned that perhaps irrigation could be uh, an influence on how wounds heal. So the water moving over the wound, perhaps that is helping it to heal better. So looking and proving if that's actually true, that could be a future study. And also looking at our methods, if there's better ways to measure. There's not really a set standard on measuring scars in cetaceans. So trying different things, this linear surface area method, they're pretty similar, but maybe there's other ways to measure. And looking at how they measure scars or patterns in other animals. So there was a study done with wild cats, looking at cheetahs and jaguars and looking at the patterns of their fur, and they just took a subsection of the fur and they analyzed the patterns within that area and they applied it to the whole body. So maybe looking at just sections of a dorsal fin as opposed to the entire dorsal fin could yield different results if we focus on maybe just smaller areas. The depth of a scar, we could also think about ways of measuring depth, because that could influence the rate that a wound will heal. Or looking at the source of scars. So a scar caused by a boat propeller is definitely going to have a different impact on the animal, but also on the healing rate compared to a fishing line. So seeing how do they, not only how do they impact photo identification, but looking at their healing rates. So seeing if future analysis, as we collect more data, is going to yield similar results is kind of where we're at right now. But the study is significant because it shows that scars are not reliable over a 6-year period. And this is a really novel area of study. There's not a lot of studies done on salinity and cetaceans. So starting to look into this area is pretty important for researchers who are trying to do studies on these animals, conservation work, and they need to be able to reliably recite them. We need to know what is a reliable identifier that we can use for those studies. And those are my references. And I'd like to thank Texas A&M Corpus Christi and the Department of Life Sciences, the McNair Scholars Program, to be able to conduct this study, Annabelle Hernandez, who's been so helpful through the whole process, the Texas Sea Life Center, and Will McGlone, who's been so helpful in providing photos and ways to get out on the water and collect data. And the Functional Anatomy, Behavioral Ecology, and Marine Mammals Lab with Dr. Dart Orbach and all of her interns in the lab there and their feedback, and also Dr. Xavier Gonzalez for lending me the tablet so that I could perform some of my methods. And that is all I have. Thank you so much for listening.